Good morning, everybody. I'm really delighted to be here. I've been to Romania before, but I was never in Bucharest. So I've been to Iași and Cluj, but I was never here. So I'm really delighted to be here in Bucharest. The nice thing is, this is such a good conference with such good speakers that I was wondering, what can I still add, right? So I'm not going to spill about the new OpenJDK 20 or some other features of some other frameworks or specifics of Kubernetes or whatever. The only thing I can add is basically my personal journey. And it's my personal journey through code and through traveling because, well, if you speak at conference, you're okay with traveling a bit. So this is a picture I took 2 weeks ago in the Philippines. And so this is basically combining my love for traveling and my love for code. So bear with me, and I'll talk you through everything that I've been through in the last 40 years. So what I really like to do is I like to travel and I like to write code. And the nice thing is I was talking to Alex last night, and we sort of see there's an analogy between traveling and writing code. And it can give you this, like, it's hard to describe, this feeling of pure joy, right? If you write code and it works, or if it doesn't work and it frustrates you, which is about 98% of the time, right? It can give you this adrenaline, well, whatever, right? And it's hard to describe that feeling. And that feeling never left, right? And I've been writing code for a very long time, meaning I'm probably going to do this for the rest of my life. So, but I also travel a lot. And I found this word on the internet called travelist. Basically, I was misspelling something because I have a book which is called The Ultimate Travel List. And I misread it, and I came up, what's travelist? So I looked it up. It's actually a word. And there's a website that is called the Travelist something. And they say, being a travelist is like those who wander for wonder to fully experience, it's a long sentence, so bear with me, a new locale, the culture, the people, the approaches to the everyday common task we all endure, to learn to be inspired, to deepen the soul, enlighten the spirit, and refreshen the mind. That is basically that same feeling, right, of ultimate joy when you get out of a plane or from your car and you're in this environment that sort of inspires you deeply, right? And that's the same with coding for me. And it started a really long time ago. So this is the HP 25. You've probably never seen it before. I actually still have it, by the way. This is my dad's pocket calculator. My dad was a mathematician and a civil engineer, basically. And he bought this thing because it could be programmed, right? And yes, it could be programmed. So I opened up the book. I was 11 years old at that point in time. And it basically says, for those who read Dutch, it says, effortless programming. There is nothing effortless about programming anymore, right? It's become too difficult for each to grab it into our minds. But we could effortlessly program this HP 25. So it had a very elaborate manual. This is a book, by the way. For those of you in the younger generation, you can actually turn pages and then read stuff. And it's quite nice, actually. I actually learned to program from books. There was no internet when I learned to program. I had this really thick Turbo Pascal black book, which I learned programming from that. And that was very different than how we do it now. By the way, with all the GPT stuff coming out, we don't need to learn programming anymore, right? It can do it for us. Sort of. But anyway, so this is the manual, and my dad, being very meticulous, he wrote the date in it that he bought the device. So it's the 24th of September, 1977. So this is where my programming journey started. And it hasn't ended yet. I haven't written any code today, but yesterday I was in the airport and I had too much time, so I was writing code in the airport, and I write code basically every day. So that's it. So analogy to the travelers thing is, you can also say I'm a codist, which means being a codist, those who fully experience the new locale, in my case, NLNL, the culture, the people, the approaches to the everyday common task we all endure, to learn, which is very important, to be inspired, to deepen the soul, enlighten the spirit, and refreshen the mind. So for me, writing code and the pure joy of that matches that of traveling, actually. And the thing is, about writing code is actually what's most essential to that is learning, right? So this is the great programmer Aristotle. Quite near, he has a beard, so he must be a programmer, right? So he says it's for the things we have to learn before we can do them, we need to do them. And that's the point. And every time you look into well, how does learning work, you see the same analogies. If you go to martial arts in Japan, you see the same thing, right? You learn from a master. You've all seen the Karate Kid, right? The original one, not the one that was crafted 20 years after. So where Mr. Miyagi tells Ralph Macchio to wax on, wax off, or the other way around, I always forget. And he does that because it needs to be in his muscle memory. And it's the same with learning other stuff, like riding a bicycle or writing code. It needs to be in your muscle memory. So you learn and you copy from someone who's done it before, or you read a book. And eventually, you learn to detach. You learn to see that you have this toolkit now that you can use to solve problems that were beyond where you were before. And eventually, you get to the point where you can transcend, which is typical Zen-like, right? So you can sort of figure out when this toolbox actually applies and when not, and when to use other stuff, and how to combine that other stuff, like maybe introduce AI into your workflow and see what happens then. So it's about learning to experiment as well. And that is basically where the Zen stuff comes in, right? Because I looked up the definition, right? It says, well, a state of calm attentiveness in which one's actions are guided by intuition. That's the thing, right? It's not anymore a logical process, but I follow these patterns and then I get this code. It becomes intuitive. If I look at code, somebody else's code, on my team, my own code, I'm almost like, there's something, I feel this, and it's like, I can do this better. It takes a lot of time, by the way, and then you start refactoring, of course, with tests, and then you get into code, and you're like, oh, this is much more Zen-like code. Have you had that feeling before? That is what I enjoy so much. I basically rewrite all the code my team writes, basically. That's what I do. That's my addition. So when it comes to the Zen of programming, it's basically this. You become one with the code, lost in the rhythm of the tasks at hand. Now, isn't that beautiful? That's what we do, right? That's what we do every day. And then the question is, how does learning really work? Now, there's this great book by Gerald Weinberg called Becoming a Technical Leader. It's a really old book. Gerald Weinberg had died a long time ago, but he wrote like 78 books on computer science and all sorts of stuff. They're really thick. And this is an interesting book because what this book does, it actually shows his process of learning. So what he was trying to do, as he explains in this book, is he was learning how to play pinball on the machine in his local cafe. Have you ever tried playing pinball? Yeah, right? People still do that on their computer probably, but this was on a physical machine, right, with actual metal balls in it. And so he was like, my assumption is that getting better at this machine is a linear process, and I'll get better at it if I practice more. That was true, by the way. But what he realized when he started jotting down the scores and practicing a lot more is that it is actually not a linear process. It is, you get better for a while and you can do this, and at some point, you reach a certain point, I'll explain that a bit later, where you all of a sudden get a lot better. And the question is, how does that work? And he started wondering, so he actually made a graph of all his scores. And what he noticed was, right before he got a lot better, it got worse. The reason it got worse is because he started experimenting. At some point in time, you feel confident, right? You're in the middle of the shuhari mode, and you're like, what if I try this? And one of the anecdotes he had is that he was experimenting with multi-ball. Multi-ball is a very nasty thing in pinball machines, is where all of a sudden there's like 5 balls in play. Have you done that? You know what happens if you do this, right? If you do this, and I love playing pinball, so all of a sudden you have these 5 balls in play, and then all of a sudden they're all gone. Because there's no way you can keep track of all the 5 balls. And if they're all gone, the game ends. So what he tried to do is he tried to say, what if I keep my eyes on one of these balls and keep that one in play, and the other ones, when they pass by, I'll just flipper them, but no, it's probably not a good English verb, but anyway. So I'll just give them a bang, and then they'll go up or down, and they'll go out eventually, but that one ball, I'm going to keep that in play so I can continue playing. And he started experimenting with it. And when he started experimenting, first his scores went down. Because if you try out something new out of your comfort zone, it's hard, right? That doesn't only go for pinball, it goes for everything. But in the end, you get a lot better because it actually works, by the way, this trick. I tried it out on the last time I played pinball. I broke the all-time high record on a machine. I'd never done that before. It was pretty cool, actually. So you get a lot better. You get a lot better by experimenting and then figuring out how to do this. So it's sort of, the graph is like this. And this is the same with writing code. It's when you get into new stuff, you have these ideas, or you get into these bumps, and you might have this epiphany, right? what if I do multiple? What if I try to write my code slightly different than the day before? What if I make this small change? What happens? And the effects can be quite big, right? So these are the experiments you all need to go into. And it's not just about learning, it's also about unlearning. I found this really funny graph on the internet. I have no idea where it comes from, by the way. So if anybody knows, I'd like to mention the original author of this graph. Because this is basically my journey through 45 years of writing code, right? I started with, on the pocket calculator, which was programmable in 49 steps. There's nothing we can do in 49 steps, right? I write a lot of TypeScript and JavaScript these days. Even if I just install the Node modules on my laptop, it weighs like double the weight it normally has, right? So it's you start with super simple code that is really easy to read, really straightforward code, and then you dive into OO, and you dive into design patterns. I read the design patterns book when it came out. I'm that old, basically, right? And then you started working for large enterprises, banks, government agencies, and they say, could you please add another 11 layers of abstractions? Nobody knows why, they just do, right? And then all of a sudden you're at this point and you're like, I'm tired of all these abstractions and all these layers and all this fluff, what I'm writing. Why am I writing this? And then you quit your job. Well, I did, actually. So I was working for large consultancies. I worked for Capgemini for a very long time. And I was like, I hate this. I'm not going to do this anymore. I'm going to work for small companies. Small companies write smaller software, actually. And I got to the point that I was getting rid of all these, well, abstractions and layers and stuff. And I got back to the point where I'm now writing super simple code again. And that is a really interesting journey. The question is, what did I see in the meantime? Well, I'm going to try to show you what I saw in the meantime. So let me introduce myself a bit. This is me. You've seen the picture before, probably. I'm currently the CTO for an e-commerce company, which is not active in Romania, but I do have a Romanian developer on my team, living in Amsterdam, by the way. He is somewhere in the country now on holiday. I'm not sure where he is, but he's somewhere here. And so this company called iBoot.com, I did a bunch of CTO roles before that. I'm basically a lifelong programmer, and I'm an independent dad. I have 3 kids. They're sort of grown up. And, well, officially, right? Officially. It's like and this is me if you want to contact me. A nice thing is that I worked for this company called iBoot, and we won the Website of the Year award in the Netherlands in 2022, which is a few months back. Really, to our surprise, we were in the event, and then they announced us, and we were like, we're going away because the event finished, and then they handed out the big award, and we won. And we're like, what? How did we do this? We didn't pay for it, right? And we didn't, by the way. I asked, we didn't. So that was a nice thing to do. So again, this is me, just to prove to you that I'm vested in object orientation. I'm actually doubly object-oriented by nature. There's nothing I can do about this. It gets worse, by the way, because I live in Amsterdam, and the street I live in actually is called the Java Street. I was trying to figure out whether there was a TypeScript street, but they don't have that, just the Java Street. This is taken from my apartment, by the way. So we also write, my team and I write a lot of open source. Writing open source is nice because you cannot change your own code anymore because there's other people who might use it and you don't know that. That's a nice new challenge, actually, that we figured out. So I'm always on this quest for like super simple code, right? How can I make my code even simpler? And in hindsight, when I created this talk, I was like, I've actually always have done that, to make code simpler than it was before. But depending on where you are in the graph, that can still lead to very complex code, right? So the thing is, I'm going to show you a bunch of these realizations, these epiphanies that I had over time, but bear with me, right? So here's the thing. It starts with realizing that it never ends, right? You're never there. I've been programming for so long, I still learn every day, right? There's little things that I see in my code. I'm like, oh, what if I try out this? I had this epiphany in the airport yesterday. I still need to figure it out how to put it in the framework, but I'll figure it out later today probably. And you still have these like, oh, wait, we can do this too, right? All these little potholes that you have and getting better after it, it still happens. And the nice thing is, throughout your career, this will continue to happen. I have never not have this. So I suppose during the rest of your career, you'll also have these moments. And the thing is, you need to realize them. You need to be aware of it so you can make much more use of it. It started for me with this nice metaphor of a wall in the desert. My first consultancy gig, I had this mentor called Wim. Wim is retired already. You can see that by his gray hair. But Wim is actually one of the most magnificent programmers I've ever worked with. And he said, programming is like this. You're walking in the desert. There's a thick fog. You cannot see further than this, right? Imagine walking in the desert. There's nothing there. And he said there might be a wall. You don't know it, but there might be a wall. And you might bump into that wall at any given moment. And you have no idea, right? This is what programming is about. You're walking nicely in the desert, and all of a sudden you're completely stuck, completely frozen. And you have no idea where to look for a solution. Recognize that point? You do, right? We have that like once a week, probably, maybe more often, depending on what you do exactly. And the thing is, and this is hard to explain to managers, but it gets to this. This is the famous programmer Donald Rumsfeld. No, he's not a programmer, he wears a tie, right? So, and he said this about the war in Iraq, I think. So he says, well, you have the known knowns. These are the things we know. Clear stuff, right? You can do this in a waterfall process if you want. But there's also the known unknowns. That is to say, these are the things that we know we don't know. That's also okay, right? If you don't have the hang of using GPT or Copilot in your workflow yet, you will. It's okay. We don't know yet, but we'll grow into it, right? This is this stuff. Like, oh, wait, I have to do identity access management. There's like 7 good solutions for it. I'll pick one, analyze it, done. Stuff like that. But the problem lies here. These are the unknown unknowns. And I had the misfortunate idea of explaining this to the whole company during a recent town hall. And now everybody's using this on me. Like, so, oh, you cannot do this? Oh, that's probably an unknown unknown, right? But it is actually really bad. The unknowns are the ones we don't know. This is the stuff we really have no idea. This is the wall in the desert, right? This is where you might bump into stuff or you might not. You have no idea. And that is basically why the stuff we are doing is so much unplannable. Because a lot of it is stuff we don't know yet, right? So every manager that tells you like, yeah, so I get all this agile stuff and DevOps and AI and whatever, but when is my project done? And he's going to be disappointed because in most cases we don't know that. I had a discussion with our CFO earlier this week, and he's very in control, right? He's from one of the big 4 consultancies, and he studied at a business university, and he's like really blue. And he's like, yeah, it's very convenient that you say that you cannot plan it, right? But you should be able to plan it. And I'm like, nope. I said, bye. I'm going, bye. So this is the thing, right? We cannot do this. We cannot plan this stuff. And that's a realization that will help you survive in this industry. So all these managers, and this is an actual spreadsheet from a team I work with. I moved out the actual names, right? This manager tried to figure out what was the individual productivity of his developers. This is like crazy, right? And he continued to do this. And it's like, stop doing this because there's no way we can talk about the productivity of individual developers. It doesn't exist, actually. We shouldn't be talking about productivity at all, actually. I tweeted this a while ago, and I said, well, basically, because we don't produce software, right? It's not like, oh, today I'm going to produce 2 software. It doesn't work like that, right? We don't work like that because every situation is different from the previous one, which means it requires a different solution, which means we might run into these unknown unknowns. And it gets worse because also the same CFO, we work in an open office, and I was sitting with my team, and I was in a call, so I could see what was happening in the back because my own camera was pointing backwards. And he was looking at me, and in the end of the afternoon, he came to me and he said, so Sander, you're assumed to be quite okay in what you do, right? I said, yeah, apparently. And so you consider yourself a good programmer? Yeah, well, sort of. And he said, but I saw you look up things. And I'm like, yes. I said, so, but why do you have to look things up? And it was totally out of his comprehension that we need to look up things every day. It doesn't happen in his field, right? And I realized that he lives in a very different field. Also, he thinks that if you're not typing, you're not working. And it doesn't work that way because the code actually doesn't live in the keyboard. The code lives in our head, right? This is where our work is done. And our mind doesn't work from 9 to 5. It's not how we do things. And Ken Beck worded it really nicely in a conference I was in 2003 in Aarhus, I think it was. He said, I'm not going to refactor the code just yet because the code doesn't know where it wants to go. And I was sitting in the front row in this talk. That's why I took this picture of Ken Beck posing as, no, whatever you think of it. And I was like, what? What is this, right? And it got to me much later. Like, if you're working on a piece of code and you cannot get the solution, you can crunch on it all you want, but you're not going to find it, right? So you step away. You take the weekend off. You go to the forest or whatever, or drink a lot of beer, or whatever you do, play with your kids, go football, play guitar, whatever you do, right? And all of a sudden, when you're in the shower 2 days later, you're like, wait, that's it. I have it. That's one of those epiphanies, right? And you cannot force that into, let's say, into time boxes, or even worse, into 9 to 5. It doesn't work that way for us. Our minds work very differently. They work like this, right? This is what our managers think we do. Oh, you get into the office, you drink some coffee, you talk about your red code, and then you go to lunch. It's not how it works. I have a lot of my ideas when I'm in the airport waiting for my plane to Bucharest, or when I'm in the shower, or when I'm in my bed, or whatever, right? You get these ideas all the time, and you need to process them. That's what we do. And as a result, we need to keep our heads clear. And the best way to keep your heads clear is by not doing this. This is in India, and you can pack a lot of stuff, right, on a little moped. But so the thing is, you need to travel light. You need to keep your head clear. That means we have to battle complexity. Neil Ford, he actually has this nice quote about this. He says, well, developers are drawn to complexity like moths are to a flame. We love complexity, right? We're always attracted to it. We add more layers than we need. We think about, oh, let's create this because it's more flexible, it's more generic, so we can reuse that stuff later. Gregor Hope even puts it better, right? He says, excessive complexity is nature's punishment for organizations that are unable to make decisions. Try saying that to a government agency, right? In the Netherlands, but that's just in the Netherlands, right? Government agencies waste a lot of money on software development, which they don't understand. But that's only in the Netherlands, right? So, so the thing is, we are indulging into what I call premature optimization. I'll give you some examples. So, and you've probably all said this, right? So I'm going to build this in because, you know what, we might need this in the future. You've done that, right? Yeah, I see you nodding, right? So, or eventually we will need this, right? We don't need it now, but eventually we'll get to this point. Or if I write my code a little bit more generic, we can actually benefit from that later. Or this one, which is also, this one I've been struggling with my whole life. It's like, what if we want to replace this database binary at some point in time? I see you've been there, right? So you write all this code in there, you use 20,000 ORMs into your code, which you don't really need at most times, just to be able to replace the database by another database. Who's done that? Okay, so the rest of you, stop doing this, right? It's like, why do we do this? This is what I call premature optimization. And you need to watch these words in the sentences you all use, right? Like might and in the future, eventually, later, at some point in time, what if. Remove those parts from those sentences because you really, really don't need it. And writing code with more writing it more generic than you need, adding more layers to it just because is unnecessary pre-optimization. And the thing is, you shouldn't do this because you can only use your time once. So you should spend it on the stuff that you really, really need to solve. Eberhard Wolf has a nice quote on this. He was talking about microservices, and he said, well, you know what? If you do who's of you doing microservices? Too few. It's just so nice to get more complicated stuff, right? So, and he said, well, basically, a lot of people start doing microservices because they think they have a scalability issue. Most companies don't have a scalability. We're not Netflix, unless you work for Netflix, of course. But so I was the CTO for an insurance company, and we started doing microservices in late 2014. So we built this first small Java component, put it on a JBoss container, a single instance. We ran it. We ran some tests. And we could log into it 68,000 times per hour it was. And we were like, we don't have 68,000 customers who are going to log in 1 hour. Not even if they all wanted to, or we send them a voucher or whatever. They're not going to do this. So we're good. And we stopped spending time on scalability issues. That saved us a lot of effort, I can tell you. Still, the project lasted for 4.5 years. Because, well, basically, we always have Hofstadter's law to screw things up, right? So it always takes longer, right? Even if you take into account Hofstadter's law. So the question I learned my teams to ask themselves and ask me all the time, which is quite annoying, is, do we really need this now? Right? Every time somebody proposes, oh, we could build this. You know what? We could use, we could build our own translation engine. Sure. Takes a lot of time, but why not? The question is, why not? Because, well, we don't really need this now. And if you don't really need this now, don't do it. So, that's harsh, right? Because you always need to favor simplicity, right? Always, every time. Because code is not a product. Code is actually cost. Every line of code you write needs to be tested, right? You do test your code, right? It needs to be deployed. There needs to be a pipeline. There needs to be a database. Well, oh wait, we need to update the database too when we deploy this feature. It needs to be maintained for like 25 years to come. That means that every line of code you write costs money. That also means that if you write code, and this is typically what I would do, right? This is a jest test in TypeScript, and this is code from one of my colleagues on my team, and I was looking at it, I can make this simpler, right? So I rewrote it, and now it's this. It's the same code, does the same thing, but it's just less code, right? Less code means it's easier to read, means it's easier to test, means it's easier to maintain. So be aware of that, that writing code is not a product. Code costs money, actually. That doesn't mean I'm very much in favor of only using no-code and low-code tools. You can use them when they're applicable, same as any other tool, but that's the thing, right? Write less code. So the easiest code to need to maintain is the code that you don't write. Simple, right? It's that simple, right? And so I looked at my own code over the years, and I'll show you some of my code. This is some of my code, recent code. Again, this is TypeScript. I do a lot of TypeScript these days. And they're single-line functions. Why are they single-line functions? Well, because this is all they do. And can you always write single-line functions? I think, well, at least one statement functions, right? And especially if you start chaining them and using monads and using functional programming, yes, functional programming, then you can actually start doing this. And your code will become less. And there's one more thing that I started realizing that I started doing is that every time I write a new function, I start with the word return. And that changed basically the way I look into code, because we were used to writing, let's say, a procedural approach to writing functions and code and classes and whatever, right? And it's like, oh yeah, we do all this stuff, and in the end, something rolls out. What if you reverse that? What if you say, let's start with the fact that I need to get something out, and then start realizing how to get there? It reverses the order of your code. And that is actually, for me, that was a really nice realization, because it helps me get to these one-liners. And that was an interesting epiphany, right, that I had. Let's see if there's more. Let's talk about naming things a bit. So here's a nice little thing that we have in Java called the abstract annotation config dispatcher servlet initializer. It's a thing, actually. And what we tend to do, and this is what we tend to do as developers is, if we write a signature to a function, and it has a variable, and the variable has a type, and this is the type, what do you name the variable? Usually what people do is, they use the same name as the class, except they use it with a lower a in front of it, right? If you do that, all your function names will be like this, right? And the reason we do this, I think, it's because I'm an old guy, right? It's because we used to have development tools that weren't as smart as the ones we use now, right? We didn't have IntelliJ or Eclipse or Visual Studio, even Visual Studio Code. We had, like, editors, which meant that if you write long functions and you declare something on the top of the function and you're in line 255, you don't know anymore what the type of it is. And you couldn't hover over stuff to see what the type. We can do that now, right? Which means we don't have to name our variables similar to our classes or types, right? We can do this much shorter. So I started delving into that, and I started delving into naming stuff shorter. Again, this is a piece of TypeScript. I'll show you some other languages as well. But so, I started doing this. Like, we have gateways and repositories, and instead of naming these things the profile repository, first of all, I shortened this up, right? It's now repo. It's much shorter. Saves you 6 characters. Good stuff. And but I started naming it profiles. Why? Because I want to say profiles my profile. I don't want to say profile repo get my profile, Doesn't make any sense, right? Why would I name a function getMyProfile if the class that it's on is already, or the instance it's on is already named profiles? It is about my profile, right? So you can leave out a lot of stuff. If you have, well, let's say, well, another repository like whatever. Well, it's the same example, basically. But so you don't have to name the stuff after the classes or the things that you are using in your signatures anymore. You can just use them in one characters, like P. P is really good. I love this because this, well, basically, it's a profile, so I know it's a profile. These are a bunch of translations, so I call them TS. That makes your code a lot shorter, right? Just try it out, right? I know we don't do that in most communities, but just try it out. Have this epiphany. See what it does to your code. You can still read it, especially if you use like IntelliJ or Eclipse or whatever you use these days, or NetBeans. I saw a guy using NetBeans earlier this week. I thought that was, well, gone already or something, but still there. So it makes your code shorter, meaning more readable. Also, don't do this, right? Do not leave commented out code in your classes and in your files and in your repos, because it confuses people. I was actually looking at this because I'm like, why is this actually, it does pretty much the same, doesn't it, or not? And you have to check, and oh wait, there's a padding left here, what does it do? Where does it, it's commented out. Throw it away. You're using distributed version control systems, right? You can find it back if you want to. Throw everything out, right? Don't leave, also don't leave to-dos in your code. Bunch of people in my team do that. Every time I check something in, I see all these to-dos come up, and I'm like, no idea what they wanted to do. And they've been there for like half a year, right? So it's probably should have done instead of to do. Also, before we delve into architecture, the most secure code you can write is no code. Because every line of code is a possible security breach, right? Be aware of this. So write less code is the point. Let's talk a little bit about architecture. So this is, you know this building? It's the Colosseum, right? It's one of my favorite buildings in this part of Rome. And it's an amazing building, right? It's been functioning for 500 years. It doesn't function anymore, well, only as a tourist trap, but it used to function as a lot of different things. And they did really weird things with it. Like, at some point, they held naval battles in it, right, with actual ships. So they put water in it on the ground here, and they put water in it, and they had naval battles in it for a period of time, right? And they used it for all sorts of nasty stuff, right? Like stuff with lions and people, and so it's a multifunctional building, basically. So, and it adapts to what you want it to do. And that's the point, right? So you need to look into architecture to say, well, it needs to be able to evolve to what I'm doing. And as the great programmer Darwin says, see, he has a beard, right? So he also probably learned to write code from a book, I guess. But so he said, well, it's not the stronger of the architectures that survive. It's the one that is, oh, you can't read it anymore, right? That is most adaptable to change. That's the point. And Neil, again, says, well, and this is, he always confuses me if Neil says this. I had him explain it to me a bunch of times, and I'm like, he said, but it's such a nice quote, right? He says, an evolutionary architecture supports continual and incremental change as the first principle along multiple dimensions. It looks cool on slides. I have no idea what he means. Yeah, well, if I have to explain it, I'll be working on it the rest of the day. So I'll show you my own architecture, right? That doesn't mean adopt my architecture. It means I've been using this architecture for quite a while, and it adapts nicely to all these situations that I've been in, which is pretty cool. So I wrote this book on UML in 2003. Long time ago, nobody knows what UML is anymore, it doesn't really matter. But this architecture was already in that book. And it looks a bit like this. Of course, you have to draw architectures as onions these days. Layers are not allowed anymore, so it's an onion now. It used to be layers, but it's now an onion. At the heart of it is always the domain. So here's my entities, my enums, my value objects, my validations, everything that revolves around the domain of this particular part of code. Around it, I would say I have like the repositories and some factories and maybe some services which deal with the entities and stuff, right? You get a repository, you get all the profiles out, which was basically the profile repo I showed you. Something we do, but not a lot of people do, is distinguish process logic. We put them in stuff called use cases. And you think there's these little ovals in the old-fashioned diagrams? We have them in code as well. So they're like called manage comment or get topic or stuff like that. So they have a little bit of process logic in them. And for us, it makes sense because they're also a good unit of authorizing people to order. They're not allowed to do this use case or not, right? So because I'm now using microservices, they have a service interface, which means There's resource classes that actually the endpoints land, and you can do a request, and it passes on the request to whatever in the architecture. Pretty simple, right? So I'm not saying adopt this one, it's just an example. And in the end, you need to be able to go out to a database, we use MongoDB mostly, or to other services, or to third-party services, like we use DeepL for translations. It's only in the that's big. It's only in the translation service that we figure this out, and we call our own service all the time. So it's this simple architecture. But this architecture was already in that book 20 years ago. If I look into my own code bases, and this is a as you can see, C# code base from like 15 years ago probably. It has the same structure, right? It has a data layer, it has a domain layer, it has a process layer somewhere with use cases in it, and in this case it has a front end because it's a website. It's the same architecture. That means that if you write code according to a architecture that is simple to explain and reusable, that you can do this. So this is, again, an example. This is a repository of one of my code bases from 2008. It looks pretty much the same, right? It gets you instances of, in this case, collections of, we named it the domain collection. I wouldn't do that now, but it gets nodes out. Okay, that's what it does. Pretty simple. Here's one in Java. But I have to warn you, this is Java in a functional style. So it uses monads, it uses the try monad. I'll get to that in a bit. It's the same thing. Different language, different platform, different style of coding. It's essentially the same thing. Or here's one in Python. Pretty recent, actually, 2018. This was from my team before I joined the team. And this is what my team now does. We now do it in TypeScript, right? So, okay, we had like 6 developers doing TypeScript. 2 of them do Python. So what language do you choose? Well, in this case, it's TypeScript. Could have been the other way around, and then we would have written Python-style code. But it's the same thing, right? These are all repositories fitting into the same architecture. And that is nice because we now, in my current client, we have over 150 different repos with code in it. We do microservices, we do micro-applications, we have workers. They're all on their own repo. All of these repos with their own pipelines have the same structure. So that means if anyone on my team wants to delve into any one of these code bases, they know how it works. And that's a good thing. Even if it would have been written in different languages, which some of them are. They're still in Python, a bunch. There's even some PHP in it. But they all have the same structure, which means anybody can delve into any one of these code bases. And that's a good thing. So enough about architecture, but if you want to read more, this is our open source project. Please star it. That would be nice. We're almost to 100 stars now on GitHub. Yeah, well, that's not a lot, I know, but it's hard to compete with other frameworks. We don't, right? But you just write it for fun. So you can read more about this there. So let's get into the complexity of writing code. Writing code is hard. You know what? We're in an industry that constantly changes. I was looking up React state management libraries. And I got to this website that says, here's the 32 best state management libraries for React. I'm like, what? 32? Why do we need 32 libraries to doing managed state? But it gets worse because these are the 32 best React statement libraries. What I don't even want to know if the rest functions at all, or are these all abandoned projects or whatever, but there's a lot of them, right? And it changes all the time. And that is the core to our industry. It's best explained in this little framework. Do you know this thing? It's the Cynefin framework. I'll explain it to you really, really briefly, right? So if you are in the clear zone, that means for every problem in the clear zone, there is a best practice. They actually exist, right? If I want to do, so if there's dishes on my sink, I'll put them in the dishwasher. My kids usually don't do that, so I have to do it myself. Simple solution, do it, right? So that's the thing. If you're in the complicated zone, then there are good practices for the problems you have. If you do identity access management, there's like a bunch of things you can use. You can use it from Microsoft or from AWS or from Google or from Okta or whatever vendor you figure out. You need to make a choice, right? So there's good things available. You need to make the choice, do some analysis, and respond to that. Just implement it. This is still pretty much plannable stuff, right? This is not the unknown unknowns. The problem is we are mostly on the left side of the diagram. We are usually here, either in the complex or in the chaotic zones. Meaning, if you're in the complex zone, you do have like this dot on the horizon that you're going to. In my case, we are implementing French as a language now, and we're rebuilding our checkout, which is quite complex, basically. It's one of the most complex pieces in our landscape. For us, this is new. So we need to figure out how to do this. At best, you hope that some practices emerge. They do, by the way. So that means we're not here, we're here. which is good because if you're here, eventually you'll go over, once you've done it, you'll go over to that side, right, to the plannable side. That is what my managers want me to be in. Could be worse, meaning if you have no idea where to go, the only thing you can do, again, is these potholes, is experiment, right? So Liz Keogh words it quite nicely. She says, well, if you all know how to do this, you're on the right side of the diagram. If somebody on the team has done this, you're still on the right side of the diagram, right? If someone in the organization has done it, if you have 3,000 developers and you can find the people who've done it before, well, it's okay-ish too, right? You're sort of on the boundary. But if you are here, right, if somebody's done it but not here, not in this context, not in our company, or nobody's done this before, it's closer than I thought it was. So in that case, you're in trouble. You're on the right and left side of the diagram, meaning this. So this is Dave Snowden. He wrote the Cynefin framework, and he says, well, the chaotic but also the complex domain, actually, they're always the best place for leaders to impel innovation. If you are on the left side of the diagram, you should say to your managers, listen, we're on the left side of the diagram. And they're like, what? And then you have to explain Cynefin to them. Then it becomes hard, right? And then you go into the unknown unknowns. And then you can say, dude, what we really need to do is we need to experiment. We need to figure stuff out which we don't know yet. And that is unplannable because we're on the left side in the Cynefin framework. Cynefin is a really interesting choice to explain to people that you cannot estimate, right? You'll remember this because you will have to make estimates, right? The best estimate you can make is just say 42. By the way, about estimates, if you ever have to make an estimate, I'll give you one small tip, is put a dot in it and two numbers behind the dot. Like, don't ever say it's 10. Always say it's 9.85, right? Why? Well, people believe you better if you put two dots after. It doesn't have to have any meaning, just do this, right? So it's 2.45 story points, whatever that may be, right? So do that. So here's the thing. If you are here, that means there are no best practices. That doesn't mean there's no practices. It does mean that there are no practices that are universally valid, right? Because every practice you can find might be valid, but within a certain context, right? We deliver stuff. We do a lot of Terraform. Basically, he does that. And, his head is a lot bigger than it is in reality. But that's all good, children. So anyway, so he does a lot of Terraform, and he writes our pipelines, and he's extremely good at that, right? I don't know a lot about it. But again, we write it to deploy it to the Google Cloud Platform, which means it doesn't work on AWS, because it's a good practice how we do stuff. It's not a best practice, because there is no universal best practice in this. There's some good stuff, right? If you talk about cohesion and coupling, we've been doing that for 40, 50 years probably already. These are good principles. Or like in the Unix philosophy, you can say, well, you should write programs that do one thing and do that one thing well. This really sticks. And if you get into more modern books, like if you talk about, let's say, the solid principles, this basically adheres to the single responsibility principle, right? Everything you do should have a single goal, right? I break down all of my code into services, into small applications, into even smaller functions, because they all need to do one thing and one thing well. And that is, to me, one of the core practices that I realized that I was doing. And you can easily find this stuff, right? If you go into Python code, and the file actually has it's actually 352 lines, this is not following single responsibility, right? Most of the classes that I have, most of the functions that I have are really, really, really tiny, back to one line or one statement code, right? Or if you have a repository with 5 gateways in it, that probably means it does too much. And you get code like this. Even when you do it in like a monadic style using promises and stuff, this is to me already something I find hard to read, because it does too much, meaning you should have split it up. Usually your architecture helps you, right? But you can redistribute stuff over the different responsibilities in your architecture. All the types in your architecture should also follow this, right? They also need to do one thing and one thing well. If you're a gateway and you can talk to a database, that's what you do. That's all you do, right? You're not responsible for formulating whatever queries you need to write, and weird queries if you do Mongo, but it's just, okay, I can have access to the database, I know how it works, give me a query, I'll handle it for you, I'll give you back some JSON. That's what you do as a gateway, for instance, right? So single responsibility. One thing that helped, and this is a tough topic, and I'm still going to do it, right? So I'm going to talk about monads. And people are like, oh, not again. It's like, people have been trying to convince us to use monads for years and years, and it never succeeds. Well, that's because the problem with monads is, as soon as you understand how they work, it becomes impossible to explain them. So I'm going to try. So my journey with monadic code started here. I was the CTO for an insurance company. I had a team of 40 Java programmers. We were doing the first microservices project in the Netherlands. One of the guys in my team came up with this. He said, there's this class in Scala that I would really like to try out in Java. I would really like to build it in Java and see if it can influence our code. And we did. So he and I took off and we implemented the class, and I didn't know what it was, basically, right? This is 2014, I think, 2015 probably. And he said, yeah, we can do all this stuff like map and flat map and filter and whatever and get. And I was like, what is this stuff? And he said, well, this is a monad. This is the try monad. What a try monad does, it takes away the necessity to write try-catch blocks everywhere. I'm like, okay, sounds good. I hate try-catch blocks, so let's do this. And then we got to this point, right? We started building this stuff. And then I read about Douglas Crockford. And Douglas Crockford says, well, monads are amazing. And you can have this really complicated definition of monads, like they're a monoid in the category of something category theory, which nobody understands. But he says, well, monads are amazing. They're simple things, almost trivially implemented, with enormous power to manage complexity. True, by the way. But understanding them is surprisingly difficult. Most people, once they have the aha moment, seem to lose the ability to explain them to others. So I'm going to try to do that anyway. And even worse, I'm going to do it in 1 minute. Because this is not me doing a talk about monads. I could do a talk about monads if you want to, but this is me trying to help you into the epiphany of maybe we should try this out one time, right? Maybe this is something that could help us write better code, write less code. You can do that, actually. So what do monads do? They take away side effects. How do they do that? By putting the stuff that you want into a box. So you have this object, whatever object it is, you put it into the box. The monad is the box, right? So this is the box that takes away the side effects, which means to get stuff done on your object inside of the box, you need to pass it functions, lambdas basically, right? Anonymous functions, and you can say, well, it's going to transform the object inside of the box, but it takes away the side effects. So that means if I have a try class, it does the try catch for me. And you can do this all the time, right? You can chain it and chain it and chain it, and eventually you'll need to get stuff out of the box. So they always have functions to get stuff out of the box. And you might say, why would you put this in a box? Well, because the box can take away all the side effects that you want, right? Like logging, or maybe even printing, or putting stuff in a database, or try-catch blocks, if statements. We barely write any if statements anymore. In our code bases, as soon as we started doing this with the try class in the big Java project we were doing, by the way, we were replacing 18 million lines of COBOL code and 12 million lines of Java into a microservices architecture that nobody had done before in the Netherlands. Nice challenge, right? We succeeded. Took 4.5 years. We resulted in 350,000 lines of code instead of 30 million. It was pretty cool. And it wasn't only due to the monads we use, it was due to we had a good team that worked really hard right away. But this is nice stuff. Because what it can do, and this is an example, this is TypeScript, or well, it's basically JavaScript with a code on it, but it has this statement, right? It has a promise, and you can say then. In this case, it takes away the asynchronous behavior of your code. The nice thing is, the functions that result here are usually pure functions. Or I was in Germany earlier this week, they say, reine Funktionen. I didn't know what it was until I thought, oh, wait, it's a pure function. And that means that they have no side effects. It means that they become easy to test. It means that they have single responsibility, which is really cool. And again, so there's we build our own monad. You can build your own monads for everything you want to, right? This is saying, oh, when this is not defined, just reject. It works within an asynchronous behavior. I'll give you some other example. This is a choose. This basically is a switch case statement, but all the functions in here are captured into a try-catch block. So I know this thing doesn't break out or fail. Worst case, it ends in the else. But it doesn't break, right? There's no, you don't have to write any try-catch blocks around it because they're inside of the monad. So can you do this in Java as well? Yes, of course. There are monads in Java. Here's the optional type. Do you use it? This is a monad, basically, right? And I'll show you the try monad for a second, right? This is how we used it, right? Okay, you put something inside of it, and then you start adding functions to it, right? This is, okay, I'm doing something from a gateway. This doesn't break because this lambda is actually executed inside of the try class, right? The try class handles it, so the try class also handles the exceptions, giving me something else to respond to, which is not in the code here. But so yes, does this work in Java? Oh yes, it does work in Java. Not a lot of people seem to be convinced about it, so I asked my good friend Chet, and Chet said, well, yes, well, they're basically a debate. Still, right? You can do this since Java 8, right? Since we have lambdas in Java, yes, you can do this. So, but it's still a matter of debate, right? And I'll show you later why that is. And what you need to do to figure this out, try it out, right? Do some experimentation. That's the whole thing, the whole key to it, right? So I'm going to leave you with that thought, right? So go ahead and try it out. So back to the complexity. What is it with complexity? And I'll give you a quote from Edsger Dijkstra, who's a famous Dutch computer scientist. He says, the programmer has to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. What does he mean? By the way, he said this in 1984, I think. And that's a coincidence, by the way, the year. But it means that our industry has gotten so complex that there isn't a single developer out there who knows it all. True? Do you know everything you're doing? I don't, by the way. By far not. So to give you an example, this is the stack of my previous client. When I got to this client, and they were making smart thermostats, and they said, could you do the chief architect role with us? I'm like, okay, so what are you guys doing? And I had the developers, there were 20 of them, come up with the list of everything they used. And this is more or less it. And it grew over time, basically, because there was no brakes on it, right? So they just continued to add stuff to it. It became more complex all the time. The infrastructural costs for this company every month were higher than their revenue. Just the infrastructure costs. They went bankrupt, by the way, so that was nice. Well, not nice, but they got bought by a large energy company. It's how it works. And but the thing is, if you have to maintain a stack like this with 20 developers, there's no way on earth that you can do it. And the realization I got from this, that I'm like, dude, I don't know about half of this stuff. I know nothing, completely nothing. And that's okay, because I am on the left side of the diagram in this. So is the rest of the team, which means we have to experiment. I'm going to just repeat this on and on, all right? And experimentation means you learn by doing, just as Aristotle said, right? So you need to do them before you find out how it works. It's the same with monads. It's the same with all the small stuff that I showed you. And how you do this? Well, the good thing is, most of us work in teams. And I find this really nice quote on the internet says that, well, the smallest unit of software ownership is not the individual, it's the team. This is the point, right? We cannot write software on our own. We have to rely on the other people in our team. Here's my team, by the way. These are my people. This is the people I rely on every day. And it's nice. So we got into, by the way, this is Eugene. This is Eugene. He's from here. But he lives in Amsterdam, so he's good. No, just kidding. So, I have to be careful with saying stuff like this, right? So this is the people I rely on every day. So, again, it comes down to, well, let's say single responsibility principle again, right? So what we tend to do is we figured out that everything you can do it can be boiled down to this. So what is the small problem that we're trying to solve today? Not tomorrow, not eventually, right? But only what are we going to do today? And we do this every day in the stand-up, which, by the way, I'm missing now because I'm standing on this stage. They have their stand-up today, actually. But it's a fully autonomous team, so they'll handle it without me. And then the CEO is usually saying, yeah, but who's in charge when you're not here? And I'm like, what, the team? Yeah, but who in the team is in charge? The team. Depends on the context, right? So anyone could be in charge depending on what topic we're trying to solve today. It doesn't have to be me. I don't make the decisions. I just write them down. That's my role as a manager, right? I write down decisions. No, it's like, I don't manage stuff. I just write code, basically. So here's what you do. And we figured this out over time, right? This is one of the nicest epiphanies that I've had in my long career, is that every big team, because you need a big set of skills to solve the problems we need to solve, right? You need, in my case, 12 people, could be 20, right? Could be 40, could be any number of people, depending on the size of the skill set you need. But for every small problem there is, you need a subset of those people. And if you leave that to the team, they'll follow it up immediately, right? So they'll come into, oh, there's a topic we need to touch. Oh, you know what, I'll pick it up, because either I know a lot of it, or I don't know anything about this stuff, so I want to figure this stuff out. So yesterday we talked about adding French to the automatic translate. We tried to translate the content of the products we sell to French automatically using DeepL, and so we need to put that in somewhere. So yesterday we got to this point that we are now here to do this. And one of the developers on my team, Gisela, she's going to pick this stuff up. And she'll probably be joined by somebody else, right? Who say, oh, yeah, no, I'll come and help you out. I also want to know how this works, or I know how our translation service works, which, by the way, they changed the API earlier this week, so my code didn't work, which is okay. I'm away anyway. So you pick the topic, you form the team. This is all organically, dynamically, right? You discuss the work, you do the work, you check the code in, done, and you repeat the next day, or after 2 days, or a half day, or however, how big the topic is, right? But they're really small. And we have everything automated, right? We have our pipelines running into production in like 5 to 7 minutes, automatically into production because we tested everything, and so does everything. So they form these teams all the time. People work in the team with different people every day or every 2 days. And I've been seeing the same pattern for now probably like 8 years. Ever since the point I try to invest in the autonomy of the team. As soon as you give them more autonomy, meaning less rules basically, they start doing this. It's a nice pattern. So I'll give you some examples, and then we get to the end of the talk, right? So this is an operations guy and a Java developer, and they're working on some infrastructure here, right? This is to Java developers and a tester. Guess who the tester is? Yep, it's the guy standing. That's what you do, right? You leave them standing so they go away. It's like you remove all the other chairs from the office, and then, no, it's kidding. Here you see 2 Java developers working on a piece of code. It's probably a difficult code because Dominique is looking really, really tough now, right? This is kind of cool, right? This is a really, really, really gentle guy. He lost 30 kilos in the last 2 years. He's now got a girlfriend. He didn't have that before. Here you see a developer and an architect. You can see who the architect is, right? Because he's praying for the code to work. And the developer's like, I'm pretty sure it doesn't work, right? So this is a nice pattern that we use all the time. And I don't have to do anything for it. This goes automatically, right? If I now would listen into the stand-up meeting that we're now having, as well, they just finished, they should finish in about a minute, probably. We take half an hour for it because we like to chat to each other, and then we just continue in different chats, and we go on the whole day, right? And it's a pattern that really works. And the nice thing is, you don't have to do any for it. Just take your hands off and give the team more autonomy. So one last small topic. This is my mom, the one on the left side, and we're having dinner. And I just got back from a trip through Italy. I was touring through the south of Italy with my kids and my girlfriend. And we got back, and I had dinner with her, and I showed her the pictures, and she was like, why didn't we, meaning my dad and her, why didn't we ever go to Italy? And I'm like, well, I have an easy answer for that. It's because you always went to the same campsite in the south of France for 25 years. There's nothing wrong with that, by the way. They really love to do that. And they went there for 25, everybody knew them, all the local bars around the Mont Ventoux, everybody knew them, and they were welcome, and it's nice. But they keep on doing the same thing, which is okay, except if you want to have a change, right? If you want to do the experimentation, you want it to succeed, and you want to change the way you write code, the thing is, you cannot reread the same chapter all over again. You need to go out and invest. Stick your head out. Again, you don't have to, right? You can always go to the same campsite for 25 years and retire really happily. There's nothing wrong with it, again. But if you want to do, let's say, functional programming in Java, as an example, right? So I'm not saying jump onto it every day. So again, I asked my friend Chet, so why are people against functional programming in Java? And the answer, she or he, I'm not sure if it's a she or a he. What do you think? The answer it gave is it's the community. Well, there are some developers who are hesitant to adopt functional programming and may be resistant to change because they're the people who go to the same campsite in France for 25 years. And that's okay too, right? But it doesn't help you go out because some people might like to change, some people just don't, right? But if you are in the position that you want to be able to change stuff, I actually tried this out at my local football club. This is a cool experiment. If you're the first to enter into a parking lot, try this out. Put your car in the wrong way and see what happens. You might get a Post-it note under your, on your windshield wiper, but again, other people will follow, right? So if you want to change stuff in your environment, in your team, in your company, in what you are working on, there's only one person who can ignite the change, and that is you. This is how new parking lots are treated in Bucharest. Yeah, I saw that, yes. I should take this picture might even have been taken here, right? I need to investigate that. So then, for one thing, you should never be afraid to ask the questions that seem stupid, because they're not stupid. They help you to develop. They help you to jump the fence. They help you to experiment, right? And then you should never stop learning. Also, by the way, never ever forget to have fun, because this is the best industry that you can be in. One last remark is, this is my personal tip, is take your mom out to dinner more often, because at some point, you might not be able to do this anymore, right? So, thank you for being here. I hope you enjoy the rest of the conference. I'll be here for the rest of the day, as long as there's beer, and well, I'll be here anyway.